Today we're taking a look at section 6-3 on applications of the normal distribution. In the last section we talked about the standard normal distribution. In this section we're talking about non-standard normal distribution. So basically what we do is we convert our scores or our data into z-scores to make it into a standard norm distribution. So we have two formulas we have to work with. The first one is the z-score formula. We take our data value minus the mean and divide it by the standard deviation to get our z-score. And we can look the z-score up in the table. So will you be using the same tables we did in 6-2. We also sometimes will be converting z-scores into the actual scores themselves. And when we're doing that, I've rearranged the z-score formula, and basically what I'm doing, and let me see if I can get my ink tools to open up. Go. I don't know why that wants to close on me, but anyway, we'll open it back up. Okay, so basically what I did was I multiplied both sides by sigma, and so the sigma cancel out over on the right and I get x minus mu. And then if I add mu to both sides, I get x. So just rearranging it, x equals mu plus z times sigma. So that's where that actually comes from. Let me erase my scribbles here so that you have the actual formula there. So those are the two formulas that we'll be using in this section. And so what I've done is I've taken a couple of examples just to give you an idea of the type of problem that we'll be dealing with. Example 1 says adult IQ scores are normally distributed with a mean of 100 and a standard deviation of 15. What percent of the adult population would have IQ scores above 138? What percent would have an IQ score below 112? So let's take the first question. Okay, so our mean IQ score is 100. That's our x. And our corresponding z-score for the mean will be 0 because 100 minus 100 is going to give us a 0 in the numerator. Okay, so I want to know what percent of the IQ scores are above 138. So that's what I want. But what I need to do is find the z-score that goes with 138. So I'm going to take 138 minus 100 and divide it by 15, which is the standard deviation. Now, when I divide these, I want to carry it out 2 decimal places because that's what the table has in it. So I take 38 divided by 15, whoops, and I've got 2.53. So now I want to go to the table, and it is a positive z-score, 2.53, and I get 0.9943. Now just like in the previous section, the area that's given from the table is the area to the left of the z-score. So what we need to do is the probability that x is greater than 138 equals 1 minus 0.9953, which is 0.0047. Okay, our second question. What percent would have an IQ score below 112? Okay, here's 112. So we're looking below, so we want to shade to the left. So again, we have to find the z-score divided by 15. So that's going to be 12 divided by 15. 12 divided by 15 is 0.8. Okay, so that would be a 0.80. And again, it's positive. 0.80 is 0.7881. So in this case, the probability x is less than 112 is what we just looked up in the table. So as you can see, basically we're adding one step to these. We're having to calculate the z-score. This is the part that's added to what we were doing from last time. So it's basically the same thing except for that one additional step. Okay, the other type of question goes in the other direction, just like we did with previous section. What we're doing is we're trying to figure out what score separates the top from the bottom, and I see I should have a Q there. Using the IQ score information from example 1, what IQ score separates the top 5% from the bottom 95%, and what IQ score separates the bottom 15% from the top 85%. So we'll take the first question first. The top 5% from the bottom 95%. So we can see it's going to be a positive z-score. We need to look up the area 0.9500 in the table. We want to get as close to that as we can, and it's between 0.9495 and 0.9505, exactly halfway. So 1.645. So that's the z-score. What we want is the x-score. So in our case, our mu was 100. Our z-score is 1.645. We just got that from the table. And 15 is the standard deviation. So 100 plus 1.645 times 15. So I'm getting 124.675. Typically, IQ scores are given to the nearest whole number. So we would have an IQ score of 125. Okay, now, what IQ score separates the bottom 15% from the top 85%? So again, we want to look up the area to the left. This time it's going to be a negative z-score. 0.1500. Okay, we have 0.1515 and 0.1492. That one's a little bit closer, so negative 1.04 is our z. So we're going to take 100 minus 1.04 times 15. 100 minus 1.04 times 15. It's 84.4. And again, if we round that to the nearest whole number, we would get 84 for that. So again, we're carrying it out one additional step. That is, we're having to calculate the x. So, thought I had the highlighter. Okay. So this is the extra part that we have to do in each case there.